Hey, let's talk about mean absolute deviation. You're going to feel super awesome by the end of the lesson today because you'll be able to find the mean absolute deviation and you'll feel like, I can do that. So let's get started. Let's explain what mean absolute deviation first, also known as the MAD. So the mean absolute deviation tells how far away the numbers are from the mean. I should have given you more room. I apologize. So how far away the numbers are from the mean. Let me tell you what I mean by that. When you have this set of data right here, the mean is 5. And you could see, yeah, I could see how 5 is like my balance point, and that's kind of how the middle point, right? The fair share. So the mean is 5. Well, if you look on this one, the mean is also 5. So if we were just looking at the mean, it would be hard to tell much else besides that. You wouldn't be able to tell and say, well, in this graph, the numbers are either really high or really low. You wouldn't be able to say, well, in this graph, the numbers are all pretty clustered, really close together on around that center. And so that's what the mean absolute deviation does. The mean absolute deviation for this set of numbers is going to be smaller because they're all closer to the mean. Whereas the mean absolute deviation for this set of numbers is going to be a lot larger because these numbers are a lot further away from the mean. That's what the mean absolute deviation is. So how do we find it? Well, I'm about ready to teach you. Let's look at this one. This is a dot plot that shows the ages of gymnasts registered for the school team. The mean of the ages is 10. So they already added and subtracted to find the mean for us. That was very nice of them. Now we're going to find the mean absolute deviation. So the first thing we're going to do is figure out how far away these numbers are from the mean. Here's what I mean by that. All of these girls right here are 8 years old. That means they are all 2 years away from the mean. This 9-year-old is only 1 year away from the average or the mean. These 10-year-olds are exactly the average. These 12-year-olds are 2 years away from the 10-year-olds, and the 13-year-old is 3 years away. So what we do now is we find the mean of these numbers. So we add and divide. All right, so we're going to go 2 plus 2 plus 2 plus 2 plus 1. Now we don't really need to add up all those zeros, do we? And now we'll add those 2 plus 2 plus 2 plus 2, and we'll add up the person who is 3 years away from the mean. And we will get 2, 4, 6, 8, 10, 12, 14, 16, 18. Did you get 18? I'm going to add that again. 2, 4, 6, 8, 9, 10, 11, 9, 10, 12, 14, 16, 18. Yes, I got 18. Okay, so I've added and now we divide for the mean. And now I'm going to remind myself, I'm going to count how many gymnasts there are. So there are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 12 gymnasts. And I'm going to grab my calculator for that one. It's going to be a little over 1. 18 divided by 12 is 1.5. So we can say that on average, or the mean absolute deviation is 1.5. So with the gymnasts, we can say, all right, well, the mean ages of our gymnasts are 10 years old. And the mean absolute deviation is 1.5 years, 1.5, meaning majority of our girls are within 1.5 years from that 10-year-old mean. Okay, that's what it shows. So, oh, look, we were supposed to do all that right there. Oops, my apologies. Moving on. Let's do that let's just keep practicing. The number of magazine subscriptions sold by 2 teams of students for a drama club fundraiser is shown below. The mean number of subscriptions for each team is 4. So both of these teams averaged 4 magazine subscriptions each. That's the fair share. If they all sold the same amount, they all sold 4. So make a dot plot of each data set. Using counters for the dots, draw a vertical line through the mean. All right, so here's 3, 3, 4, 5, 5. So that's team A. Team B over here had someone who didn't sell any. They had someone who'd sold 1, someone sold 4, and a couple awesome students who sold 7 and 8. Okay, so what we do now is, remember 4 is our mean. We're now going to find the distance that all the numbers are away from the mean. We want to see how far away from the average they are. So we've got 1, 1, 0, 1, 1. These guys are, let's see, 0 is 1, 2, 3, 4 away. Means this one's 3 away. Then we have 7, which is 1, 2, 3 away, and 4 away. So now we add them and find the mean of those distances away from the mean. So 1, 2, 3, 4. We have 4 here. We'll divide that by 5. And 4 divided by 5 is 4/5, which is 0.8. And then here we have 7 and 7 is 14. Divide that by 5 because there were 5 people on that team as well. 14 divided by 5 is 2.8. So what we have is team A's mean absolute deviation is 0.8. Team B's mean absolute deviation is 2.8. So here's what we can conclude from this information. Team A, they all were very close to the mean. That means they all sold about the same number of magazine subscriptions. Whereas Team B, they had a much bigger mean absolute deviation, meaning they had a much bigger spread of how many subscriptions were sold. And we could see that here, obviously, right? We had some that didn't sell hardly any, some that sold a lot, and then one person that was right on, correct? So it shows that, oh man, they had some overachievers and underachievers, right? And you didn't see that with Team A. Everyone, because that was so small, they're all very close to the average. Team B was much further out. Their MAD was a lot bigger. How we feeling? All it needs is more practice. So, where's my next page? Right there. We're good. We're good. Let's find the mean absolute deviation without doing the dot plot. Let's speed up the process just a little bit because we're all about that, aren't we? So the number of laps Shauna swam on 5 different days. We have all of the laps here, Monday, Tuesday, Wednesday, Thursday, Friday. The mean is 7. And we're going to find the mean absolute deviation now. So 5 is 2 away. 6 is 1 away, 8 is 1 away, and 10 is 3 away. Let's add all those up. 2, 3, 4, 5, 6, 7, 8. Divide it by the 5 days. And 8/5 is 1.6. So this tells us that she, on average, swam 7 laps. Give or take like 1.5 laps. Sometimes she went almost 2 more. Sometimes she went kind of 2 less, just kind of depending on the day. That was her spread from her average. Okay, so let's look at Lara now. Lara also swam laps for 5 days. Her mean was also 7. So both of these girls can say, I swim an average of 7 laps a day. Okay, so Lara's mean absolute deviation, 1 is 6 away from 7, 3 is 4 away, 0 away, 3 away, and 13 is 6 away. So when we add these up now, we get 10, 13, 19. Divide that to get the true mean of those numbers. 19 divided by 7 is, we're going to round that to 2.7. So her mean absolute deviation was much higher, wasn't it? So what she'll say is, yeah, my average is 7, but I can vary a lot more from that. Sometimes I swim a lot less. Sometimes I swim a lot more. Okay. So out of both of these, who would you say is more consistent of a swimmer? Well, Shauna looks more consistent. Her mean absolute deviation, she doesn't deviate much from the mean, does she? Whereas Laura is a big deviator. Oh, let's talk about that word deviation. If you deviate from something, you go away from it. So if you're very devious, you go away from what is right and you do naughty things. But numbers, when they deviate from the mean, it means that they spread far away from the mean. And they can show that they're more spread out and not as consistent. So that's kind of the opposite of the word consistent. So Shauna's pretty consistent, whereas Laura's not so consistent. She's a little more devious from the plan. If the plan is to swim 7 laps a day, she deviates often from that, right? We can see that with the 1 lap she swam that day and the 13 laps she swam the other day. She's not very close to that mean. Okay, you probably are ready to try some of these on your own. So if you want to pause and try it, or just try it with me, let's see how far you can get before you're like, what's the next step? Okay, so the first step is to realize what the mean is. Step number 2 is to figure out how far each number is from the mean. So if the mean is 7, then we've got these right here. This is the distance these are from the 7. And third step, add those up and find the mean. So 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 24. Divide that by, let's count how many there are. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Divide that by 10. And we get 2.4 for the mean absolute deviation. How many books are read each semester? Most people read about 7 books, but that can deviate by 2.4 books mostly. Okay. How about we say that when we are shipping packages, the average weight of these packages on Tuesday was 29. Now you can see from our data that they were either less than that or a bit more than that. So my estimation, my guess, my prediction is that this mean absolute deviation will be pretty big. Because if 29 is the mean, none of these numbers are very close to that mean, huh? So we're going to see a larger mean absolute deviation. All right, so 26 is 3 away. Those are 2 away. 1, 2, 3 away, 4 away, and 6 away. So when I add these up, I get 10, 3, 6, 9, 12, 22, 24, 26. That is really quick adding. I'm probably going to catch a mistake of mine. In fact, I don't trust myself. I'm going to use a calculator. 3 plus 3 plus 3 plus 3 plus 2 plus 2 plus 3 plus 4 plus 6. 29. Good thing I added. And I better do that just one more time just to make sure. Okay, 3, 6, 9, 4, 3, 4, 6. I got 26 that time. All right, I think we're back to 26. 3, 6, 9, 10, 11, 12, 13, 14, 15, 16, 20, 26. Yeah, let's go back to 26. Okay, let's divide that by 1, 2, 3, 4, 5, 6, 7, 8. Divide that by 8. And you get 3.25. So yeah, the packages that were shipped, yes, the mean was 29, but really there was a large deviation away from that, like 3 pounds on either side of that average is really where our numbers were. All right, this is the last one. I want you to try it on your own. See how you do. Pause it, go for it, and then follow along with me to see if you did it correct. Okay, so if the mean is 11, let's figure out how far away these numbers are. 7, 1, 11, 3, 4, 5. 8, 9, 10, 9, 10, 11. Okay, now you got to add all those up. It's a lot of numbers. Better make sure you don't make a mistake. 1 plus 1 plus 2 plus 7 plus 1 plus 3 plus 4 plus 5 plus 5 plus 3 plus 3 plus 1. 36, but am I going to try that again? Yeah, I am. 1, 2, 3, 4, 11, 12, 13, 14, 15, 19, 24, 29, 30, 31, 32, 33, 34, 35, 36. Okay. I feel good about that. And there were how many days? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 days. Oh, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yes, 12, because there's 12 months in a year. Gotcha. Okay. So we get a mean absolute deviation of 3. So the days of precipitation, on average, we get 11 days of precipitation per month. Give or take, that's kind of what the math is, give or take 3 inches one way or the other. Okay, so that is your final mean absolute deviation. Good luck today. Have fun with it. See you, I'd say next time, but this may possibly be the last lesson before you guys take your test. Good job, guys.